All right, so we're just going to really briefly look at a few of these then. The first one we're going to look at briefly is question 6, and then time permitting we'll go backwards from there. So let's start with question 6. Okay, so question 6, we just need to use the LCT to determine convergence or divergence. And we have this series here, 4n over n squared plus 3. This is just polynomial over polynomial. So I'm going to try to create a p-series out of it. So let's turn this into, let's just take a look at the lead terms. The lead term of the numerator is 4n. The lead term of the denominator is n squared. Let's simplify that. That simplifies to 4 over n. If there are any constants remaining, turn those constants into 1. So basically, we're going to compare to 1 over n. Compare to the series 1 over n. Does the series 1 over n converge or diverge? Diverges. And that's the advantage of a p-series, is that you will know the answer to that pretty quickly. Yeah?
What if when you plug it back in, you're going to get, like, you're not going to get a constant? Or you can do that?
Now that's going to parts 2 and 3 of the limit comparison. Part 2 says that if you get 0 and the denominator converges, then the numerator converges. Part 3 says that if you get infinity and the denominator diverges, then the numerator diverges. All right, so let's do our comparison test, LCT. We're going to take a limit as n approaches infinity. 4n over n squared plus 3 divided by 1 over n. That's going to get me the limit as n approaches infinity of 4n squared over n squared plus 3. Okay. Now there are 3 ways of showing that this limit is actually equal to 4. Remember, you can... Hey. When is it?
Thursday.
Like in 2 days?
Yeah.
What time?
6:30 to 9:30.
Tell her I'll talk to her. Okay, where did we leave off? Oh yeah, you can just take a look at the lead terms. 4n squared over n squared simplifies to 4. You can look at the lead coefficient test. You have square over square. So the limit is 4 over 1. Either way, you get 4 here. So that means that both series do the same thing. Let me type this. Both series will either converge or diverge. In other words, both series do the same thing. Since we know since we already know that the harmonic series diverges, that means that both of the series have to diverge. And so, as a conclusion, 4n over n squared plus 3 diverges. Okay? Let's look at 5. We have the series n cubed over 3n. And we want to determine convergence or divergence. Now you have a bunch of things you can use. Just to name a few of the tools you have, you can of course use the nth term test. You can use a ratio test, certainly. You can use a geometric series test if applicable. If applicable, you could use what we just used, the LCT. You can even use the integral test. You have all of these tools to use. P-series. Yeah. You have all of those tools to use. Now we're saying the nth term test, but that's not going to get you anything. You're going to get a 0 here. Okay. If you want to take a look at it, we're going to see.
The nth term test is when you just do the limit as n approaches infinity.
Yeah, the limit as n approaches infinity of n cubed over 3 to the n, that's equal to 0. So basically the nth term test is inconclusive. So we need to move down to another test. And I think the best test to use here is the ratio test. So let's use number 2, the ratio test. We're going to take the limit as n approaches infinity of n plus 1 cubed over 3 times 3 to the n times 3 to the n over n cubed. Now this is not a power series, so we're not going to make that less than 1. We're not looking for an interval. We just want an answer. Okay, so let's simplify that. You get the limit as n approaches infinity of, now I'm always really bad with expanding cubes. Is that n cubed plus 2n squared? Or is it 3n squared? You think it's 2n? 2n plus 1?
Yeah.
Or should it be 3? It should be 3. 1, 3, 3, 1. Over 3n cubed, right? Okay, so this is another case of the same thing. It doesn't matter what you do here. You can look at the lead term over the lead term. N cubed over 3n cubed simplifies to 1/3. You can use L'Hopital's rule 3 times. No matter what you do, you should get 1/3. Since 1/3 is less than 1, the series is going to converge. Yeah.
Something that was greater than 1.
Diverge.
Did you ever get a 1 plus x?
There are no x's to start off with.
But if there were,
If there were, then you would automatically set this less than 1.
and then if you get that it equals 1, then you go on to another test.
Go on to another test.
Yeah, because then if it's
Mr. Ferris, is it valid to set it equal or to make it less than 1 from the beginning?
No, you don't want to do that. You only want to set it less than 1 for a power series.
Okay.
Okay? Yeah,
What was that? If it equals 1, you go down to another.
you go to another test. Okay, and I think the last one I want to do at this moment is question 4. That'll get us done with pretty much everything. So let's look at 4. 4 we have, again, convergence or divergence of n cubed plus 8 over 6 to the n. Okay, so let's not mess around. We know that our LCT, no, it's our LCT. We know the nth term test is going to get us 0. So we'll go right to the ratio test. So we're going to take the limit as n approaches infinity of n plus 1 cubed plus 8 over 6 times 6 to the n times 6 to the n over n cubed plus 8. Not a power series, so I'm not going to set it less than 1. Okay, that is a simplify. That simplifies into, what is that? N cubed plus 3n squared plus 3n plus 9 over 6n cubed plus 6 times 8 is 48, right? Just like we said before, there are 3 ways of doing that. Lead term test, L'Hopital's rule, or simply a ratio of the lead terms. You should get this limit equals 1/6, which is less than 1. Bless you. Therefore, that series converges. If the limit's greater than 1, the limit it diverges. If the limit equals 1, you move on to another test. Okay? Shutting it down.
Do you number 9 on there? Shut it down.